going to build up a case by taking into account a traction motor. So let's start by introducing our traction motor used for this analysis in this session. It's based on the 2010 Toyota Prius electrical motor as published by the Oak Ridge National Lab and Professor Jim Hendershot. The objective here is to optimize the design and reduce the magnet volume while maintaining the required performance to meet the Freedom Car standards, as well as the safety and reliability. So the motor consists of 48 slots, 8-pole IPM machine. The key factor we need to notice here from this table is that the magnet volume that we are, our objective is to minimize this magnet volume and reduce the weight and maintain the performance required by the peak torque and the peak power. So to achieve our objectives, we're going to break down the technical roadmap or the technical work into 3 main steps. The first step is the design inputs, and this is usually, in our case, we're basing our design based on a traction motor that is already designed, but in other cases you might need to design the motor in the first place. So when designing the motor, you have to take into account the peak power requirements, the electrical drive that is going to be connected to the machine, the geometry and the materials used for that specific design, as well as the stator windings and materials and so on. From there, we go into the design optimization, where we take a look at the performance. For this specific case, we're looking at the performance and the magnet volume. So we have 2 competing objectives. We would like to minimize the magnet volume while maintaining the performance, and at the same time, we'd like to minimize the cogging torque to make sure that the electric machine that we're designing is as smooth as possible. And the last step, we're going to go into the multi-physics design. So we're going to take a look at the demagnetization analysis, a detailed demagnetization analysis, some eccentricity analysis, and CFD analysis as well. So to start off by the design inputs, again, this is the machine that we're doing. It's a 60 kilowatt machine developing 205 Newton meter at 3000 RPM. The magnet volume is the same. It's a 3-phase winding, distributed winding with lap winding, 1 coil per pole per phase, single layer winding, 11 turns per coil, and 12 strands in hands. So before we jump into the tool and see how we can first establish the baseline design,